in matrix number KIL180080. Today I want to present about the step-by-step solution to solve the CPP past year question. This is the question from 2012 and 2013, question 7, which is a reactive single unit question. Methane and oxygen react in the presence of a catalyst to form formaldehyde in methane oxidation reactor. In the parallel reaction, methane is oxidized to carbon dioxide and water. The feed of the reactor contains equimolar amounts of methane and oxygen. Assume a basis 100 mole per second of feed. The fractional conversion of methane is 90% and the fractional yield of formaldehyde is 0.855. Calculate the molar composition of reactor output stream and selectivity of formaldehyde production relative to carbon dioxide. Also carry out degrees of freedom analysis. And this is the block diagram for this reactive reaction. And this is the input, which my basis is 100 mole per second, and the weight percent for the CH4 and O2, which are 50% and 50%, and the outlet, which are formaldehyde, water, carbon dioxide, methane, and oxygen. And first, we need to do the DOF analysis, which the number of variables are 6. And number of equations are 4 material balance plus 2 reaction, which are the conversion of methane and the fractional yield of formaldehyde. And next, we use the fractional yield of formaldehyde to find the product of the formaldehyde. By this, we can find the molar composition of formaldehyde, which is 42.75 mole per second. And after that, we can find the C1 from this equation, which is also 42.75 mole per second. Next, we need to do for each of the product. For CH4, we can use the fractional conversion of methane to find N4, and N4, which is 5 mole per second. And from this equation, we can find the C2 for the second reaction, which is 2.25 mole per second. And for H2O, N2 is equal to 0 plus C1 plus 2 C2. And which is 47.25 mole per second. For CO2, N3 is equal to 0 plus C2 equals to 2.25 mole per second. And for O2, N5 is equal to 50 plus negative 1 times C1 and plus negative 2 times C2. And the answer is 2.75 mole per second. So the total molar flow rate in the outlet is N1 plus N2 plus N3 plus N4 plus N5, which is 100 mole per second. And we can do for the question asked in the question. So for the molar composition for formaldehyde is 42.75 over 100, and it is 0.4275. And for H2O is 0.4725, CO2 is 0.0225, CH4 is 0.05, O2 is 0.0275. And last is the selectivity of the formaldehyde to the carbon dioxide. The molar flow rate of the formaldehyde is 42.75 mole per second, and for the carbon dioxide is 2.25 mole per second, and the answer is 19. For the second question is the non-reactive single unit mass balance question. is from 2013 and 2014 past year question. Question 2. A material is to be dried in hot air and the moisture content reduced from 20% to 1%. Fresh air contains 0.02 kg of water per kilogram of dry air. Find mass and volume of fresh air required. If 100 kg dry material is to be produced, the acid air contains 0.09 kg of water vapor per kilogram of dry air. Air enters at the 300 Kelvin and 1 atmospheric pressure. And for the block diagram, this is a dryer, and the dryer has 2 inlet and 2 outlet. One of the inlet is wet material, which has 20% of H2O and 80% of material. And for the hot air inlet, which has M2 kg water and M3 kg of dry air. And for the outlet, hot air outlet contains 4 kg of water and 5 kg of air. And the dry material outlet has 1% of water and 99% of material, which is shown in the question, is dry to 1%. So first we have to find the mass of the content and mass of the H2O. The mass of the content is 0.99 times 100, which is the basis of the question, and we found that is 99 kg. And mass of the H2O is 0.01 times 100 and equals to 1 kg. And we need to find the water feed to the dryer, which is 99 per water feed equals to 80 over 20, which shows in the inlet of the dryer. And the H2O feed is 24.75 kg. And H2O being dry is equals to H2O feed and minus H2O balance, which is 24.75 kg minus 1 kg equals to 23.75 kg. So the water being dried per kilogram of dry air, which shown in the question, is 0.09 minus 0.02, we get 0.07 kg. 1 kg of dry air is equivalent to 0.07 kg of water being dried. So the water feed to the dryer is 23.7 kg of water. So we can know that there are 339.3 kg of dry air in the dryer. Hot air inlet. In the hot air inlet, 1.20 kg of dry air is equivalent to 0.02 kg of water. So we found the mass of the dry air is 339.3 kg of dry air, so it's equivalent to the 6.653 kg of H2O. So, and the fresh air is equals to hot air plus water, so is equal to 346 kg. And we can find the mole of the dry air, which is 300, the mass divided by the molar mass, which is 339.3 kg over this. And 0.21 is the composition of oxygen in the air, and 0.79 is the composition of nitrogen in the air, and 32 is the molar mass of oxygen, and 28 is the molar mass of nitrogen. So we can find that is 11.765 kmol. And we use the equation PV equals to nRT, and we can find the volume of the dry air is equals to 289.63 meter cube. And for the water, density is equals to mass over volume. So volume of the water is 6.653 times 10 to the power of -3 meter cube. So at the last, volume of fresh air is equal to volume of dry air plus volume of water. So it's 289.63 03 plus 6.653 times 10 to the power of negative 3, and the answer is 290 meter cube. So that's all for my presentation. Thank you.